Hi everyone! Today we want to talk about privacy and healthcare. This presentation introduces the Privacy Shield, a conceptual privacy framework for health information generated by wearable devices. The work is grounded in peer-reviewed research published in PLOS ONE and addresses the growing tension between pervasive health monitoring and personal data protection in wearable computing environments. The paper positions privacy not as an optional feature, but as a foundational design requirement for wearable health systems. Healthcare is no longer confined to clinical settings. Wearable devices enable continuous remote patient monitoring, personalized wellness tracking, and increased patient autonomy. Empirical studies cited in the paper demonstrate that smartphones and wearables are already reshaping healthcare delivery by lowering costs and improving accessibility. However, this shift also expands the attack surface for sensitive health data. Despite technological maturity, privacy protection mechanisms in wearable ecosystems have lagged behind innovation. Existing systems often prioritize data collection efficiency over user control. The paper explicitly identifies the risk of misuse of protected health information, PHI, as a structural problem rather than an implementation flaw, warranting a new conceptual framework. This slide highlights the core motivation of the research: the absence of a user-centric, end-to-end privacy model for wearables. The framework proposed in the paper is not device-specific. Instead, it is designed to be OS-agnostic and applicable across smartphones, smartwatches, and future wearable platforms. The conceptual framework is introduced as a complete privacy protection package composed of 2 structural layers: 10 privacy principles and actionable technical checklists for devices and applications. This dual structure bridges policy-level privacy requirements with practical engineering guidelines, addressing a gap in prior frameworks. So, our new framework for wearable healthcare systems enhances privacy and security. It includes secure data transfer, port security, and encryption. Users can manage apps, control data, and authorize access. The framework ensures data collection is transparent, with a systematic personal health record database, allowing users to edit or delete data anytime, maintaining a chain of trust. The first pillar defines 10 principles centered on user sovereignty, purpose transparency, and robust security. The paper formalizes privacy as continuous control, meaning users can edit, revoke, or limit access to their health data at any time. These principles extend beyond confidentiality to include transparency, ownership, and accountability. Unlike abstract regulatory frameworks, this work introduces concrete checklists for both wearable devices and companion applications. These include secure communication ports, strong authentication, user-manageable interfaces, and the novel inclusion of a moderator and privacy guard, a capability not present in earlier healthcare frameworks. This slide contrasts conventional personal health record (PHR) architectures with the improved, privacy-centric PHR proposed in the paper. The new model distributes trust across components and enforces policy-aware data flows, reducing reliance on centralized repositories that historically posed privacy risks. To validate feasibility, the framework is applied to a real-world healthcare scenario: a post-surgery cardiac patient using a Samsung wearable. The case study demonstrates how privacy principles operate dynamically during daily health monitoring, not just at setup time. This slide walks through operational stages such as device setup, encrypted data transfer, location privacy, and device loss handling. Each step is mapped explicitly to corresponding principles and checklist items, illustrating traceability between theory and implementation. The framework demonstrates that improved health engagement and privacy protection are not mutually exclusive. Patients receive alerts, recommendations, and motivational feedback, while insurers and third parties only access explicitly authorized data subsets, reinforcing minimal disclosure. The framework is evaluated against CIA principles, confidentiality, integrity, availability, and HIPAA requirements. Comparative analysis against ONC, HPP, BP, CF, and CCHIT shows that the proposed framework uniquely integrates protection safeguards with user-controlled monitoring, strengthening compliance and resilience. This slide consolidates the research contribution into 3 dimensions: user-centric design, implementable developer guidance, and a fortified PHR architecture. Our paper argues that privacy must be treated as an architectural constraint, not an afterthought. Our research explicitly calls for interdisciplinary collaboration among developers, healthcare providers, policymakers, and researchers. It highlights that technical frameworks alone are insufficient without regulatory alignment and enforcement. This paper presents a conceptual privacy framework for health information on wearable devices. It emphasizes safeguarding personal data while enhancing device functionality. This work as a foundational reference for future research in wearable security, privacy-preserving health analytics, and trusted digital health ecosystems. Please read, share, and connect with us for collaboration.